We're on. Fantastic. So good afternoon. My name is Dr. Gary Ellem. I'm here from the Tom Farrell Institute for the Environment at the University of Newcastle. The Tom Farrell Institute is the Environment and Sustainability Institute of the university. And for our sins, we are quite interested in clean tech industry development. And the Hunter Valley is actually a really big hotbed of electric vehicle manufacturing. We build electric trains and electric mining equipment. So something a little bit, when we say electric vehicles, most people think electric cars, but we certainly don't in the Hunter Valley. We think about heavy industrial stuff because that's what we actually build. So we initiated the Hunter Valley Electric Vehicle Festival really to put that on the map. You're probably quite used to arguing for support for manufacturing in the car sector, but no one seems to think about the heavy vehicle sector at all, and that's actually a pretty important sector for where we are. So we spend quite a bit of time lobbying, and the Hunter Valley Electric Vehicle Festival is one of the ways that we use to bed that down. The Electric Vehicle Festival actually has three major components to it. One of those is a behind-the-scenes industry and government policy workshop. That's to really get our ducks in a row and understand how to get that coming through. Then we run an EV prize competition. That's what I'll talk to you a little bit more about today, because I think the title of my talk is something to do with electric motorcycle racing or something. So that's the closest we come to that. So in the EV prize, we actually have a competition, and so high school students around the region build the equivalent of a small electric motorcycle. We book out a kart racing circuit for the day, and they come and they race their motorcycles against each other in what's really an endurance competition. Then we also, later on in the year, we have an EV show where we book out the entire foreshore park in Newcastle, and we have everything from remote control vehicles to dodgem cars to segways to bicycles to electric super bikes to supercars to trains to ferries. It's the most comprehensive electric vehicle festival in Australia. Last year we had about 8,000 people there, and this year we expect to get about 12. So things are going pretty well. We're all fired up. The objective of the EV prize is really to do two things. One is to drive electric vehicle innovation. So we have some categories that ask people to do weird and wonderful things. And also it's a skills development platform. It's about getting kids interested in science, engineering, technical trades, as well as in thinking about entrepreneurial things, how they start a business, how they actually package things together, how they design things, and get that all together. So that's what the EV prize is all about. It's very simple for schools. We give them a simple set of rules. Those rules are really, you've got a battery limit. That's 384 watt hours. That's really about the same amount of energy that's stored in a standard e-bike, commercial e-bike battery. And then we have a race, and the race goes for 1 hour, and the question is who can go the furthest in that 1 hour. It's a fairly simple competition. There's a few other safety rules, of course, but that's really it. We separate it into, this year, into a hub-driven competition and a chain-driven competition. The big issue around there is that now that the speed is increasing a little bit in the competition, schools are actually voltage limited to 36 volts. And any hub motor you can't gear in a different way, and so that means that there would be unfair because the hub motored bikes would be limited in their top speed. Does everyone know why a hub bike would be top speed limited by voltage? Is that obvious? Are we in that world at all? So if you think about think about a permanent magnet motor. So most of the hub motors you'll see will be permanent magnet motors. So a permanent magnet motor they're often an outrunner motor, so the magnets are around the outside, and you'll have a coil on the inside. So as those magnets are running around, technically what you've got is a coil moving within a magnetic field. That's really a generator. So what happens is as the bike is traveling along, the motor is actually trying to generate voltage to send out of the motor. And so if you want to put energy into the motor, you have to supply more voltage to the motor than the motor is trying to send to you. That's called back EMF out of the motor. So that means that the faster the wheel goes, the higher the voltage it generates, and eventually, if the voltage of your battery is 36 volts, once the wheel is spinning at a speed that generates 36 volts, you can't get any more energy into the motor, so it's voltage limited. So even though you might have a lot more power available, you just can't get into the motor because of the voltage mismatch. Now, when you're not limited by the voltage, when you don't have an artificial 36 volts limit on it, you can just keep upping the voltage and get a faster and faster motor by putting more and more voltage into it. But because schools have safety issues, they're limited to 36 volts. And so that means they can't go any further. Yep.
And what happens when if you have a chain as well to assist and you get over that 30, whatever do this, like, but it's 30 kilometers an hour, 40 kilometers an hour. You pedal at 50 kilometers an hour. What happens then? It starts regenerating.
Yeah, so it depends on the kind of motor that you have. So some of this, you see some small hub motors, they're actually freewheeling motors. So if you go faster, they'll just freewheel. So they roll. They don't do any regen, they just keep on rolling. As the bigger pi motors, I'm not quite sure. I've never driven the bikes into that configuration before and haven't quite tested what goes on. So my feeling is they'll just keep trying to feed voltage, but
they certainly have regen braking, so maybe they have regen.
So the real answer is I don't know. I'd like to be able to tell you something more in depth. That's
I guess the point though is that you can't if the available voltage limits the electric drive to 36 kilometres an hour or whatever. Anything above that, you've got to do completely by pedaling.
Yes, and so your standard hub motor. Yeah, so all the hub motors out there will be designed to top out at a certain speed. Generally, the hub motors come in two configurations. You can have a high torque motor. That actually will generate more torque for the same amount of current, but for that same voltage, it'll peak out at a lower speed. So a high torque motor will tend to top out at about 25 kilometres an hour, or you get a high speed motor, which will generally top out at about 30, maybe 35 tops. But that'll give you less torque down the line. So
I suppose the question I really asked was if assistance above that speed.
Yeah, if you try and no, so it won't give you any assistance above that speed. Yeah. The motor will top out at that speed, and that will be it. Whether if you get above that speed, will the motor become an active brake? I haven't tried on one of those pi motors above that speed. Yeah, so I mean certainly the small motors that you see have a different kind of. They actually have a standard sort of permanent magnet motor, but not an outrunner, and they have a geared system inside that, which is geared down. So they have a small motor inside that freewheels on a geared system. Slightly different. So we invite school kids from all over Australia to come. We've focused on the Hunter initially because we're a Hunter-based organisation, and that's really where we want to make things happen. And that's where we can find good sponsorship to help the teams. But next year, this year, I'm told that we'll have teams from Victoria and from Western Australia attempting to come into the competition as well, which is kind of exciting. What I'll do is play you just a little quick bit of a video. This is a video of last year's session, and that will give you a bit of a feel about how the session goes on. The presenter here is actually Danny Lloyd-Pritchard. She's one of our workers who turns out to be quite well science trained and communications trained. Right? Oops, I'll give you some volume in there.
Where today we're going to see up to 30 teams competing in an endurance race around this track. We want to see how far they can go in 90 minutes on a fully charged battery. We've got 4 classes in the competition today. We've got the sport division, which is going to see up to 20 hunter-bicycle teams competing. We've also got the open single seat division, where we've got 8 teams registered. This year, for the first time, we've even got an entry in the open dual seat division. Behind me you'll see all of the team members entering the track area. We're going to have a walk around for the next couple of minutes to get familiar with the track and to identify any hazards that may exist.
You want to go up the yellow line and start breaking out the yellow line? Take it easy for the first couple of goes.
So you see that little yellow transponder on the bike? So they're actually timed on a professional timing circuit.
You drive the new inventions because that is what's going to give us jobs in this region in the future.
What are your thoughts on the competition this year?
It gets better and better. It's a fantastic opportunity for all the people who do this, and I congratulate both CBA and Tom Farrell Institute. They've stuck at it, and really the opportunities that we've had and the innovation that exists in this part of the world, particularly around the Hunter, it's just fantastic, and I think we've got a real opportunity to lead Australia into the electrical vehicle future. So I'm very, very enthusiastic about it.
Break it, yellow line.
All right.
So go
Can you
from
tell us how the scrutineering was?
complete custom-made bikes like that.
Primarily with scrutineering is the safety of the rider. We're always make sure is that
So we go from bikes that are almost completely custom-made to bikes that are off the shelf. The rules of the competition are designed pretty much so you could put a vehicle together in an afternoon. You can buy an off-the-shelf kit, whack it on a bike, and you're in the comp. that's to help science teachers who are not so tech savvy and a bit nervous get into the competition. But once you're in, you can always improve and always improve and always make things more technical. So, we've specifically designed it in that way. So it's easy entry, but you can get more and more high tech as you enter. And some of the teams that won had completely pulled apart the control system and had done their own sort of stuff right from scratch. Some had even built their own frames. So you notice that we have good sponsorship from local coal companies. So this is New Coal, for example, which is a local coal supplier. You might not know it, but pretty much all underground mining is electric. So the mining industry needs trade qualified electrical engineers as well as electrical fitters and things. It's a critical part of the industry. We're also sponsored by the ME program, which is called the Manufacturing Education Program. That program is actually funded out of the Defence Material Organisation. In the next decade and a half, we'll have about $250 billion worth of defence upgrades. About 150 of that is going to be spent in Australia. They don't know where they're going to actually source the staff to actually do that. So it's quite important for all of those industries that we have enough kids coming through into science, engineering, technical trades to be able to fill all of those positions as things go. We're quite interested in clean tech sector development, and the clean tech sector is going to compete with those other sectors for labour. And so it's critical for us to make sure that just the number of kids coming in to fill in that pie increases. Otherwise, the clean tech sector locally will end up getting snuffed out just through competition for labour. So we're quite active at recruiting guys from the mining and defence sector into supporting this, because we're all fighting the same battle here. We're all trying to get as many kids through into science, engineering, technical trades, as well as entrepreneurialism, understanding how to start a business, how to market a new idea and market a new product, design a new product. So we work quite hard in the competition to make that happen. Quite good spread between both boys and girls. Some schools enter entire girls teams in the competition because it's an endurance race. It turns out that girls are damn good riders, and they listen to instructions, so they actually do much better than the guys in some ways. They don't just go in and go hard. They understand. They get the feel of a machine, and they understand how to take it easy. And they're also really good at teamwork, and that's an important part. So certainly designing the rules and making sure that it doesn't just become a boys' club is quite critical to us, and we feel like that's actually happening. So that's quite good. We're pretty happy about how that's working. You notice that all of the kids are rigged up in motorcycle quality gear. That's because they're building motorcycles. Even though it's on a bicycle chassis, technically the motors they're running are all about 750 watts or so. So they classify as motorcycles under registration, maybe a moped if you're lucky. The top bikes are capable of about 75, 80 kilometres an hour. So it's certainly we talk about it as an electric motorcycle race, not as a push bike race, even though they're using a bike chassis, which is interesting. What we also try and do is to link the students through into that further education and jobs on the other end. So that means that the university and TAFE are both strong sponsors of the competition and offer prizes and are present there on the day. And then often a lot of the large employers are around. We deliberately get scrutineers out of those fields. We had the head of electric vehicles from DSTO, the Defence Science and Technology Organisation, as one of the scrutineers this year, as well as a few guys, the head of electrical engineering at different mining companies around, and the professor of electrical engineering at the uni as scrutineers. So to make sure they're well connected into those things. And we also put them in the pit area with people that are at the edge of electric motorcycle racing. So in the same pit area, we had guys who are just about to leave to go for the world final for the electric superbike finals. We actually had them in the same pit area. The kids could look at their bike and look at the electric superbike and understand all of the different components and how they matched, and realise that really they were just scaling up theirs into an electric superbike. It was all the same thing. This is actually an entry into the dual seat division that we had. The rules for this were simple. It's, can you build a fully electric car capable of carrying 2 people at more than 60 kilometres an hour around a track weighing less than 100 kilograms? So that machine is actually made out of a lightweight steel frame covered in basically what is core flip plastic with fiberglass over the top. So,
Kids,
no, that was an open team. That was a family team that did that. So, a dad, and you can see inside his daughter. These guys just turn up. We also have a demonstration division. Anyone turns up with something wacky, we'll let them go into the track for a little bit of time. Not necessarily race, just for fun, just to encourage people to have a go and get things worked out. This is actually a car from the uni. They were experimenting with an electrothon type vehicle, and that's they're having a go at that. They're building up. This year we have a new class. We've got the 1500 class, which is a small electric motorcycle. So it's an electric motorcycle with a 1500 watts of power, 1.5 kilowatt hour battery, and that's a straight out, flat out race. That one for 10 laps. So it'll be a sort of like a small motorcycle scale sort of race, which is probably well suited to the size of that track. The track's actually a little bit tight for electric superbike racing. We get them out there and we'd let them have a go, but it's a pretty tight circuit and they have trouble winding up to full power, which is kind of fun. So we do quite a bit of work with the electric superbike guys as well, especially because some of those are based in Newcastle. So has anyone heard of the Catavolt racing team before? I see the name precedes them. It's good to see. so Catavolt actually run by a guy called John Eggenhausen. Back in, I think, 2007 or so, he was laid up in hospital after having a motorcycle accident and managed to watch the world's fastest Indian while he was in hospital bed, and he thought, I'd like to set a world record. That'd be good. I wonder if there's a record for an electric motorcycle. It turns out there wasn't, so he thought, bugger it, I'll build a bike and we'll go and set the world land speed record for an electric motorcycle. So he did that. He built a bike, went and raced it on the salt flats in South Australia, set the world land speed record at the time, about 177 kilometres an hour or something. That lasted for not particularly long. Pretty soon after that, a US team went much faster. And so he decided that he would go and build a new bike to go and take back the world land speed record. Built the bike, but unfortunately what happened is we got all that rain the last couple of years and all the salt flats flooded, and so he hasn't been able to race the bike. So he converted his bike to a street racing bike to race in the TTXGP Superbike Series, and has since won both the 2011 and the 2012 TTX Electric Superbike Series, and went over to Daytona at the end of last year and managed to win the World Series competition for the 75 class. So that's the class with less than 7.5 kilowatt hours of battery in the bike. He lives in Newcastle. He's now converting that bike into a ongoing a production road bike that he can sell. He's just sold the first production prototype of that a month or so ago to a local doctor, and he's starting to ramp up that production and looking at other platforms as well. So we have guys of that sort of caliber in the region, and so for us it's quite important to connect them through and play an active role with kids. So we have them running courses for kids on how to build these bikes around the place, which is lots of fun. Also lots of fun when you bring him to the racing, lets you have a ride the bike as well. That's kind of good. He's interesting because he's the only guy worldwide in worldwide racing that runs actually a hub motor. Everybody else runs an inboard motor with a chain. He's the only one worldwide that runs a hub motor, and so for kids that are often got a hub motor based bike, it's really good for them to go and say, oh, you just literally scale that up by 10 times and turn the wick up quite a bit, and there you go, you're in that sort of field, which is very interesting. This is kind of very informal, so I'm happy to answer any questions you want to throw my way.
The bike you were just talking about, Newcastle guy, what's his name again, and do you have an idea of the price? Is something that's much more?
So his name's John Eggenhausen. The company is Catavolt Motorcycles. That particular bike, my understanding is he sold the first production prototype for $18,000. So that's for a bike that's it's got a 6 kilowatt hour battery pack. It's based on a Ellem chassis and has a hub motor driving it in the rear. That hub motor's I think it's 20 kilowatts continuous and about 30 kilowatts peak. So it's electronically limited to a top speed of about 120, so it's freeway capable. It'll do bikes. Aerodynamics of bikes is actually absolutely terrible, so range is really quite dependent on the speed you run at. So if you're around town at 60, the bike will do about 150 kilometres on a charge. If you get out the freeway and open it up, then that comes all the way back to about 60, 70 kilometres on a charge. quite a good functional bike.
I see a few of the people wearing peaked helmets. Are they not as bad aerodynamically as they look?
These ones,
Yeah.
it's more that these are often country kids, and a lot of them ride dirt bikes, and that's what they've got for riding their dirt bike. And so it's really just, pick whatever helmet is going. So don't think of that as being the ideal helmet to have. Think of that as being the helmet that was available at the time for the kid that fit the head.
I noticed some of them are riding on dirt bike tyres, which can't be the most efficient.
Yeah, so depending on the school and how much they've thought about it and how long ahead of time they've had and what their budget is, some of them have just, had almost no budget and have literally just pulled one of the kids' second-hand mountain bikes out of the cupboard and given it a go and not even had enough money to put new tyres on. Other schools are really well funded, have actually bought several sets of tyres and looked at rolling resistance and competed them against each other and, have gone all the way. So it just depends on the school, the interest level, the funding level, all that sort of stuff. So we certainly, while it is very competitive for the top schools, the bulk of the schools are really just in it for the experience and for the teamwork and for the fun, and we certainly stagger the prizes in that respect. Everybody gets an award that goes in this because it's lots of fun, and we like to encourage them all. And they have a compulsory rider change for schools halfway through. A lot of the schools would actually have 5 or 6 rider changes just so that everybody got to go on the bike in the competition. So, that's what it's all about. It's all about participation. It's quite, coming into this competition really gives you faith in the future of humankind, that we might actually do okay. These kids are absolutely brilliant. We would have 200 kids all together doing something that's pretty out there. And not only, and in all of that time, you wouldn't have heard one kid being pulled up for anything at all. They're just, the people we mainly had trouble with were parents and friends. The kids are absolutely dialed in. You give them a problem, that's what we do. We just give them a problem and say go to it, and they bring all their creativity to the table, and they do really well. It's great fun. Yep.
The what hours limitation you have, is that policed purely by the multiplying the numbers of the battery manufacturer puts on his stick, or do you have a standard instrument that measures how much is actually consumed by each?
No, we say 3 at 184 watt hours nominal. Yep. So that means that if it's a commercially produced e-bike battery will take whatever is written on the label. If it's you can use a commercial e-bike battery, any commercial e-bike battery that's less than the capacity that we talk about, and we don't ask any questions at all. As soon as you've tampered with or modified the battery or the battery management system in any way, then suddenly we ask a lot more questions. And so, and you're also restricted to certain chemistries. So you get restricted really to lithium iron phosphate chemistry if you start to play with stuff, just because that's one of the safer chemistries around. It's a bit hard for them to accidentally do themselves some damage by overvolting or those things. The batteries tend to be a bit more robust as well, so if they do something silly to them, then they don't blow their battery pack and have to start again necessarily.
So if someone with infinite funds could buy dozens and dozens and dozens of batteries and test them all and pick the highest ones, they'd get away with it. But,
yeah.
Battery shop.
Yeah. So certainly can do that, and you might get like an extra 20 watt hours or something for all of that effort. So there's always room for money to make a difference. It's just the question of how much difference, and that's always been
in testing and they're learning.
Yep. So it's in sourcing. So it's always hard to try and structure a competition that's a competition at the same time as any teams are always going to have differences in the funding available, in the support they have available. Some of them have keen as mustard parents that are really highly skilled and come in and help. Some of them have, it turns out that their science tech teacher happened to be like a mad keen electric vehicle person from way back, and is as opposed to another team where the teacher doesn't have a clue and they're just trying to work things out on the fly and they don't really have much of a budget. So how to structure a set of rules that allow for schools to do new and interesting things when they think of it, at the same time as not making it so that it's not just a matter of how much money you have. And that's always a challenge for rule makers. Yeah, sort of things.
Are there any rules regarding aerodynamic enhancements?
There are some rules, but those rules are all about safety. So what we've actually done last year, the race was 1.5 hours, and it turned out to be about right. So that turned out to be the average speed was about 30 kilometres an hour, which is what we kind of expected. And this year, what we've done is moved the race back to an hour for basically the same size battery. So that will raise the average race speed by about 5 kilometres an hour. And we've deliberately done that to give more advantage to the teams that now start to think more about aerodynamics. So aerodynamics start to take hold at about 25 kilometres an hour. You start to think about it. At 30, you're sort of like you're trading off weight with aerodynamics. At 35, you just want to start seriously thinking about it. So that's why we've slowly upped the speed.
Okay, so you're seeing some interesting aerodynamics coming in?
We expect to see more this year. We had a few sort of fairings last year, but they were mainly just to protect the kids from bits of the bikes, just covering up things. We've seen some aerodynamics more in terms of bike position. So if I can, let me just try and find a bit. So you see, this bike here, they've deliberately selected that position because they thought that was a more aerodynamic riding position, and they've designed the whole bike around that. These guys here, you see they've reconfigured the position of the foot pegs. That's not actually a seat anymore. The person's lying on a board on their stomach. So they've tried to change frontal area as the main thing. So while they haven't tried to change the drag coefficient necessarily, they've tried to change the frontal area as a critical way. So this year what we've done is we've run a teacher's workshop, and as part of that we start to give the teachers